Hello there and welcome to this week's quick tip tutorial, or whatever you want to call it. This time we are going to have fun with instances and math nodes inside of the shader context of Octane. The idea for that comes from the MoGraph Slack, where a user called Satosh Prince asked about how he can achieve an effect like this. So let's jump into our 3D and create something. Okay, let's start. So the scene file we will create is in the description below. So if you are too lazy to create it your own, you can just download it and use it as an asset. Let's clone something. Since we are dealing with clones, I want the clones to move around the scene in spiral shape. So let's create a helix here. Go to object, move it to the Z axis and make the height 0. Now we have a circle, but we can move the end radius to be inside, so let's make it 2.5. And now we have a spiral. Let's make a floor real quick by adding a plane. And then we want to clone something on there, so let's add a cloner. So to clone something on there, we need something, so let's create a sphere real quick and make this a size of 0.5. Maybe 1. Yeah, 1 is better. And put it inside of the cloner. Then we want to go to the cloner and set it to object mode and move the spline into the cloner. Great, so we have our clones moving in that spiral. Couple more things to set here, so let's go to the cloner and get the count up to maybe 50. And then we will take the helix spline and move it up to +1 in the Y direction to make the spheres sit on the ground here. As for scene setup, the last thing I want to do is add a light. So let's go to the lights here and add, where's the lights? And add a targeted light and move it to -250, 250, -250. And let's render. And the result here might look different from yours. And this is because I changed the environment to be black. So I had complained about that in former videos. So users pointed out you could save a new C4D file with this turns black, and this is what I did, and it works beautifully. So let's make the light a little bit brighter by going here and set it to maybe 250 or even 500. This is looking great. So we already set up our scene. There's one thing that we need to do still, and this is set the cloner to be a render instance. Right now it's set to instance, and this is giving Octane normal objects. So every one of those spheres Octane sees as an individual object. But our effect only works with render instances or Octane instances. And as soon as we set Cinema 4D to render instances, Octane knows that it has to instance those spheres, and therefore we have the effect we wanted. So since we are not dealing with any shading effects and we are not interested in fancy shading, so let's just create a diffuse material. Let's click on the diffuse to make it visible in the nodes and actually rename it to lighting or something. And then we will go about in the material and click on diffuse and make the diffuse black, since we are relying on the emission to give us our values that we feed in. And then we will create a texture emission and maybe apply the material to the sphere here. You then see that the material is much too bright. So what we need to do here is go into the emission shader and set the surface brightness to on. And then also set the power to 1. This gives us very dark values here, and this is because the material is not fed with anything right now. So let's do this to test out whether we're getting our right values by bringing in a float, setting it to 1, and feeding it into the distribution and the texture. And you can see that now we are getting the right values. We are just getting the scene value of 1 at the lit state of the sphere. Of course, not a lot is going on right now, so all the spheres are having the same brightness, so we don't have anything to control any animation. So I want to take something that does vary the values of the spheres here and not something like a random texture that randomizes them, but I want to do it in an orderly fashion. And this is exactly the right job for an instance range. So let's search for it. Instance range. Here we go. So let's plug this into our texture slot to see what it's coming up with. And right now we can see that it's altering the instances between a value of 0 and 1. So if we type in 5, for example, we can see that now the light to dark gradient is in between 5 of the spheres. So black, 1, 2, 3, 4, white. And it is repeating that throughout of all our spheres. So the next idea I was having is, what if we create some cycle through that based on those colors? So if we, for example, add brightness to them, one sphere after the other will overexpose. So let's do this real quick. And as I promised, we are doing stuff with our math nodes. So let's type in math. And there's actually two different types of math nodes in here. That's unary and binary. Unary just take one value to do math, and binary takes two. Since adding stuff together takes two inputs, I'm going with the binary option here. Let's get this going. And it's already set to add. Let's also make it our habit to name those, so we have a better overview later. Okay, so we have an add. So we will duplicate this node here and use it as additive to that other one. So let's just do this and put everything together. And now you can see that all the spheres are white. And if I put that float value in that node down, you can see that we have our old values back. So if I start to increase that, we can see that one sphere after the other will be clipping at white. And that sort of gives us a direction in our animation already. So instead of overexposing here, I was having the idea, what if we can do anything to the overexposure to bring it back down to 0? And there's exactly that as a math option here. So let's go to our explanation chart here. So what we have right now is a value that's steadily increasing. So we go from 0 to 0.5 to 1 to 1.5 to 3 and so on. And we lose everything in overexposure at the value of 1. So we want to have something that cycles through. And there's actually a math node that's called fraction. So if you're familiar with math, there's something similar than the modulo does. So what it's doing is, if the value reaches 1, it pushes it down to 0 again. So it pushes it down, and then as the original value goes from 1 to 2, the fraction value rises from 0 to 1 again. So this is exactly what we need to get our animation going. So let's go actually back to our scene here and duplicate this math node here. And the fraction is a unary value. So let's go and say math unary and then search fraction in this list. And it's actually here. So right now the node isn't updating. So get active material here and let's bring it inside of the stream. And you can see there's something going on here. So we have now two black spheres next to each other. The reason why this is happening is that the white sphere that is next to the black sphere will be then pushed back to black. So we have a black and an actual white sphere next to each other, but the white sphere is then pushed down. And if I now go ahead and move my float value, you can see we have something like a cycling animation here throughout our spheres. So what I want to do is to automate that a bit. So I'm going to frame 0 and put a keyframe here. And then I'm going to frame 25. This is my frame rate, and put a value of 1 here and also keyframe that. Now if we go to our window up here and actually go to our timeline, there's a couple of things I want to do here. So if we roll that out, you can see the spline here is actually interpolated. So what we want to do is, instead of an interpolation, we want to use a linear interpolation, so no interpolation. And then we want to go to the float value here and set this to the state that it's doing after we want to continue. And what this is doing, it pushes up the value ever since. So it's just an ever increasing value that comes out of that. So I just need to bring in 2 keyframes here. And if I go to the float value and see here, if I move my slider beyond 25, you can see it's steadily increasing. And this is exactly what we want. Of course, you can do this with Xpresso also, but it's more complicated, and this is not a tutorial about Xpresso, but about math nodes in Octane. You might notice that the gradient looks a bit odd, and this is through the joy of output display transforms. So what we need to do is actually get a gamma correction back here. So let's type in color correction, and then bring it in here. And in the shader, you need to set the gamma to 2.2. And now the gradient looks much more linear to our eyes. So, and if I press play here, you can see that we now have some moving lights. So this is the simple setup of our scene here. We want to go a bit more advanced and make this a bit more tidy. As you can see, every now and then there are 2 spheres that are black, and this is not looking particularly nice. So let me explain what I want to do. To do that, let's plug in the instance range here real quick. So right now the start sphere is black and the end sphere is white. But when we pipe that through our fraction, and actually let's do that and call that fraction, what happens is that the start sphere is black and the end sphere is also black, because it will push down from white to black again. So what I want to do is pull down the last sphere in a manner that the spacing in color between the white and the last sphere is exactly the same as between those. So to do this, let's use some more math nodes indeed. So what I want to find out is what's the increase in value between every one of those. So I need to know the number of the spheres here. So we will need a float value to be putting in the same value as this. Unfortunately, there's no way to get in any value here. So we could have made this easier if we could have done a float value and brought this in here to be the number. But since this isn't possible, we will create another value here that is the same value. So let's create a 5 in here. Now we know that those are 6 spheres in a row. So 1, 2, 3, 4, 5, 6 in a gradient. So we need to make this +1. So what we need to do is duplicate this add node, duplicate that one here, and make this 1. Also rename our nodes here +1, and this will be our instance range number or something like this. Instance number. Okay. So we will add this. So we have 5 + 1. Now the next step will be that I want to divide 1 by whatever comes out here, because we have a range from 0 to 1, and if we divide 1 by the range here, you can get this number. So we will duplicate this node once more and call this add. Let's see, add, and call this one here divide. And also set it to be a divide. And then we will use that +1 because it's the number of 1, and divide it by the number that this gives us, so 6. So we divide 1 through 6, and this will give us this number here. So what we want to do is that the white sphere here that is black right now because it's pushed down by the fraction here is in between the same range. So what we have done right now is put the white sphere in the same range as this black to gray sphere. So if I duplicate that one more time and set this one to multiply and also call it multiply, and then put those streams together, you would then be seeing that the white sphere here is actually the value of what the sphere that was next to the black sphere was. So let's set this back to a value of 0 to be actually showing you the range in a best way possible. So let's go from the front. So we have this range, and we now extracted the value jump between the black and the dark gray sphere here. And if we put in that value to multiply with our spheres here, then this last sphere that was white before has this dark gray value that this sphere here was having before. But what we want to do actually is reducing the brightness of the white sphere by that amount, not bringing it to that amount. So what we need to do is subtract 1 by the division here, what we have out here. So let's duplicate that node one more time. Go ahead, go to shader, call it subtract, and then also set it to subtract here, and then use this 1 value one more time because we want to subtract that value from 1. And this is the value we then need to bring in our multiply here. So now, instead of a white sphere that will be turned to black in the fraction, we will get a slightly darker sphere that is in the sense of the value as far away from the black sphere as far as the next in the lower line is from this sphere. I know this can be confusing, but therefore you have the scene to download. You don't have to understand it. So once we've done that and we hit play here, you can see that we now get a much cleaner representation of our movement, and we don't ever have two black spheres next to each other. So this is much cleaner than it was before. So we have done that now, but if we want to increase the range here, so let's maybe increase it to 10, we always have to remember that down here there's a value that needs to be increased to 10 as well to make it work accordingly. So now we have value range animating with a gradient in between 11 spheres. But if I set this to 1, so there's only one altering sphere here, you can see that the effect this is having might look a bit strange, as one of the spheres is always gaining to white and then suddenly become black. So if we want the last sphere in line always be white, there's a trick too. So let's go to our first frame again. So you can see that on the first frame there's not one white sphere and not one black sphere, but a black and a middle gray sphere. And if we want to have this sphere white here, so let's go to frame 12, I guess. So that's the middle between that. The black sphere already is not black anymore, but gray. So to counter that, to make this sphere always white, what we need to do is move back our fraction here and actually divide a value in here. So let's just copy our divide, and it loses its name, so we need to rename it real quick and put it in here. And what we want to do, it seems to not worked. Okay, so now what we want to do is getting the subtract value here and dividing it So now we are getting our white spheres because this value is the fraction between those both spheres, and by dividing it back, you get a higher value. It's, as I said, it's not as transparent here, but the best thing is that it works. So we have always the last sphere in the line. So if I go back to, maybe let's make this 5 by 5 again. This no longer is too dark. This is back to its old glory without, because it's taking place after diffraction, without being caused to being a black sphere by the fraction. So we are working our way around the fraction, pushing that last sphere down to be a black sphere next to another black sphere. Whew, that was quite something, wasn't it? So there's one more last thing to do besides cleaning up our node tree here, which I will do real quick. So since we have the time here, we might want to add a time multiplier, and this is exactly as easy as it sounds. So let's just copy the multiply here and multiply the time with a value. So let me just borrow this and plug it in here. So we have a way to control it. And here, let's call this time, or let's call this speed. That's a better value to call it. So we have our control nodes here, and you have to remember that this value always needs to be the same. And then we have a speed, and let's see if that's working. It seems to be working. It's a value of 0.44 and it's very slow. So let's make this a value of maybe 5. And yeah, it's really fast now. So we've created our lights that will go accordingly. So maybe a last thing that I want to add is before the color correction here, let's add an octane gradient. So as you notice, the values right now go from white to black and then up to white again. So if we want to have a more of a sine wave here, so going to white and then down to black and then up to white again, we can do this really easily by adding an octane gradient. So let's do this real quick. Go here, add an octane gradient, make the second knot a value of 50, and then add a third knot with a value of 0 at the 100% position. And if I now play the animation, you can see it's a bit fast. So let's make this slower again. Now we have like this cycling light through here. And last but not least, make them a little bit colorful by also going in here and adding another multiply, this time not a math node, because we want to deal with colors, and the math nodes only deal with one value. That makes them faster, but we need 3 values, RG and B, for color. So let's go and add a multiply here, and then we will add a random color, and another gradient. And in this gradient, what we will do is go to the presets here, load presets, and load a rainbow. Here we go. Come on, load it. Here we go. That's what I wanted to do. So now we have a cycling pattern here through rainbow lights. I know this tutorial might have been difficult for you, as it was difficult for me to record. So I recorded this for maybe 4 hours now. So I'm really thankful I'm done with it now. Hopefully you find something nice to do with it. For example, some fun fair lights, some carousel lights and stuff like that. So yeah, that leaves me with the words I'm always saying: have a nice week and happy calculating. Thank you.